Hi, I'm Marco, and I'm a rising junior at the Dalton School. So my project is Mini POV, which stands for Persistence of Vision. And it's a little hard to see on camera. Basically, the idea is that there are these 8 LEDs that are blinking rapidly at different colors, and when it's in rapid motion, the eye can see these as letters. So what my project was, a big part of it was being able to solder everything in, and also I had a lot of trouble with that because sometimes I put components in the wrong place. So it caused me to have to desolder some things, which was a pretty big process for me, because desoldering is a lot harder than soldering because you have to get all the solder out. And I had a lot of issues with that, so there was a lot of trial and error and a lot of work put into understanding how to desolder, and honestly it gave me a lot of practice, so I know what to do in the future. And I'm just going to talk a little bit about some of the components and how Mini POV works. So for my circuit, essentially everything on the circuit is geared towards making these 8 LEDs be able to flash in a certain format. So I'm going to start with talking about the potentiometer. So what the potentiometer does is it tells the circuit board how fast the LED should be blinking. So it's basically like resistors. So it tells the current. It basically it's variable, so there's a knob here. So depending on how much current you want to flow through, you just turn the knob, and so that gives more resistance for the current or less resistance depending on where the knob is turned. And then there's also electrical capacitors and a ceramic capacitor, and what that basically does is it smooths out the voltage, so it prevents too much voltage from going in, and it basically keeps the voltage at keeps the current at a steady pace, so it doesn't either burn out the LEDs or not get them bright enough. And there's also the microcontroller, which controls everything on the board, basically allows the code to run. And there's also the 12 megahertz crystal, which is basically like an internal clock, so it allows the code to say, I want the LEDs to blink for this many seconds, because the crystal tells them like how many seconds that is in terms of like real time, because it's like a physical component that allows the code to actually have the time. Yeah, and there's also a bunch of resistors on the board which prevent the current from blowing out the LEDs. So yeah, that's my board.